Hello everyone, my name is Angel and today I'm going to explain the logic of code, program and explain the output. So the first code is based on bar chart with impact and its count. So in this program I'm drawing a bar chart to show the number of passengers who embark from each pod. First I import the required libraries, Pandas and Matplot libraries. Then I read the Titanic dataset into a frame. I use the value underscore counts function on the embark column to count how many passengers belongs to each embarkation point. Next I draw a chart using a plot and assign different colors to each bar. Finally I added the chart title and axis label display the graph. So the output of this program represents the three bars C, Q and S. The heights of each bar represents the number of passengers from the pod. The tallest bar indicates the pod with the highest passengers count. So the second question is of comparative bar chart for fare and new fare. In this program, I compare the original fare and new fare values for the first 15 passengers. First, I select the first 15 rows from the data set. Then I plot two bars from each passengers, one representing fare and the other representing new fare. Different colors are used so that both values can be compared easily. Finally, I add the title, labels and legend. So the output of this program displays two bars for each of the first 15 passengers. One bar represents the original fare and another represents the new fare. By comparing the heights of the bar, we can easily observe the difference between fare and new fare. So third program is basically of horizontal bar chart for marked and fare. In this program, I had drawn a horizontal bar chart using the marked column on the y-axis and fare on the x-axis. The horizontal bar helps when the category names are easier to read vertically. After plotting the chart, I added the title and x-axis label. So the output of this program shows horizontal bar representing fare values for different embarkments. Longer bar indicates higher fare values. So the fourth question is basically of draw a stark bar chart for fare and new fare against the first person. In this program, I created a stock bar chart for the first 10 passengers. Each bar is divided into two parts, fare and new underscore phase. This helps visualize the combined values for each passengers. The output of this program shows stacked bars for the first 10 passengers. The lowest section represents fare and upper section represents new fare. The total height of each bar represents the combined value. Fifth question is pie chart for passengers class count. Here I display the distribution of passengers based on passenger class. I count the number of passengers in each class using the value underscore counts. Then I draw a pie chart showing the percentage of passengers in each column. The output of this program is shows a pie chart divided into slice. Each slice represents a passenger's class. The largest slice indicates larger number of passengers in that class. Sixth one is dot plot between person and age. Here in this program I created a dot plot showing the age of first 15 passengers. Each dot represents one passenger and their corresponding age. The plot helps compare individual ages without connecting them. The output displays dots for the first 15 passengers. Higher dot indicates older passengers, lower dot indicates younger passengers. Seventh one is line plot against age and conjunction. In this program, I draw a line plot between age and conjunction. The age values are plotted on one axis and conjunction on values on other. The line connects all data points to show the overall trend. The output of this program displays a line joining all data points. The trend line helps observe whether the conjunction amount generally increases or decreases with age. In this program, I draw a salter point between fare and new fare. Scatter points are useful for identifying relationship between two numerical values. The output shows many points plotted on a graph. If a point follows an upward pattern, it indicates a positive correlation. If it's scattered randomly, the relationship is weak. Ninth one is scatter points between age and fare. In this program, I compare age and fare using a scatter point. Each point represents one passenger's age and fare. The output of the program explains the relationship between age and fare. It points are random where there is a little or no correlation. If they form a pattern, it indicates a relationship between age and fare. Tenth one is plot for age. Here I draw a box plot for the age column. The box plot summarizes the statistical distribution of data. It shows the minimum value, first quarrel, medium, third quarrel, maximum value and any outliers. Output of this program displays a box and a whiskers. The middle line represents the medium age. The box represents the interquartile range. Points outside the whiskers are considered outliers. 11th one is histogram for conjunction. In this program, I draw a histogram for the conjunction column. A histogram groups data into intervals and shows the frequency of values. The output X displays bar representing the frequency of conjunction values. Taller bar indicates that more passengers fall within that conjunction range. 12th one, histogram for conjunction with bin value. Here, I create a histogram using a specified number of bins. Bins divide the data into equal intervals, making the distribution more detailed. After setting the bin value, I draw a histogram. The output of this program represents the conjunction distribution divided into multiple intervals. Each bar represents one bin. The height of each bar shows how many conjunction values fall within that interval. Increasing number of bins provides a more detailed view of a data distribution. So this program demonstrates different types of data visualizations using the Titanic dataset. Each chart helps us understand the data in a different way, making it easier and identify counts, compaction, distribute strengths and relationships. Thank you.